Welcome back to the Gruber Morning Show. This is the Gruber Communications podcast. I'm Pete Gruber.
I'm Mark Schaffner, and welcome to the Wired Hour.
And today our background is an AI-generated image. The request was give us a data cabling trade show exhibit. And this is what it rendered. The picture or the poster behind me that has our name actually was gibberish, and unfortunately, so far, we have not found any way for us to be able to give Midjourney any instructions regarding text. It just continues to post just gibberish, nothing that makes any sense. The other thing that the purists may find troubling is those cables that are glowing behind us.
Yeah. I mean, I'm sure you probably told it to put fiber optic cable in there or something like that, and it just has a little bit of a different view of what fiber optic cable is than what probably is reality.
So hoping that AI learns, or perhaps learns from us, yes, fiber optic cables do not let any light escape. Even if they did, it would be invisible light because it's outside the human spectrum.
That's right.
So, but anyway, that's the image behind us. What we did in the last session, the comm group session, was we talked about some history. And for the last week, I've been digging through old images and pictures and text, and I found some more stuff that might be relevant that paints the picture how this division within the Gruber companies came to be what it is.
I'm really interested in looking at some of those pictures. From what I understand, we might see another picture of you with hair.
It's entirely possible. Do you guys have the ability to bring up picture number A-1978?
A-1978?
Uh-huh.
Let me look.
The suspense is killing us, isn't it?
Oh, it absolutely is. Well, Richard's bringing that up. Just a reminder, feel free to ask questions. We have people monitoring them. We'll put them up. If you let us know where you're coming in from as well, and that helps us to know the scope of our audience. We in some of our podcasts, we get a worldwide audience, and some of them are a little bit more stateside.
So what we have here is Pete Gruber in 1978, in his 20s, and this is outside my little home in Phoenix. I had just transitioned by 1978 from the Phoenix manufacturing plant of Digital Equipment Corporation to the field service office, which was down by the airport. And these were the folks that maintained a large contract base of mainframe computers, essentially computer rooms. They call them data centers nowadays. But as you can see, I'm standing there very proud. That is a brand new company car. I have never had a job where a company car has been associated with my work. It was, I think, a Ford Fairmont, that I think about it, and had an 8-cylinder engine in it too. And they used to give us larger engines because our territory oftentimes included mountainous areas, and the field engineers were pretty adamant about saying, you know, we can't go to Flagstaff safely. That grade on the I-17 is just too much. We need bigger, motors in these company cars, and management bought it.
They bought it.
Yeah.
Wow.
But one other difference, the guys that were working down there at the field service office generally wore casual clothes, kind of like I am, T-shirts and I was convinced that in order to overcompensate for my weaker skills than they had, I needed something. So I wore a dress shirt every day. I wore a tie every day. I wore dress pants every day. And instead of carrying a toolbox, I decided to carry a briefcase. And you know what? It worked. Even though I wasn't as smart as the other guys that had been working there for some time.
Right.
When I walked in the room with one of the other field engineers, or even more than one, the customers generally would come and talk to me instead of them.
Because you were the one that was
Exactly.
perceived, because of your dress, to have the authority.
Exactly. So anyway, that was that was me with hair. For those of you interested, let's go to the next image, and we'll play on uh, the presentation we did in the last or the first podcast, which is the roots of the company. And for those of you that saw that, if you remember, I was talking about a laundry room because the company really started in a house on 19th Avenue north of Bell. And the laundry room served as a early production facility to build AB switch boxes and do data cabling in the field. But the AB switch boxes are really what generated the cash flow to keep the company alive. Never went for loans, never had any investment partners, so it was vital to keep cash flow healthy. And this next picture that we're going to look at is B1-laundry room.
Pulling it up now.
All right. There we go. And you can see a window air conditioner in there. I recognize a lot of my old test equipment on that bench, but that was where in the evenings I would build AB printer switch boxes. Now, a quick story again there. Back in the day, mainframes, you had dumb terminals, and printers were very expensive. So you didn't get a printer at every desktop. You got one in the office, and people had to share that. And in order to share it, they had these things called AB, ABC, ABCD switch boxes. And sometimes, like you pointed out, they would cascade those.
Oh, yes.
In order to get multiple users to be able to use that same resource. Well, let's go to the next picture, guys, B2 switches. And this is not the deck version or the digital equipment version. They had a very nice brushed aluminum, highly professional switch box that cost $250. And, people were more than willing to pay for that. However, I was making these in this little room that I showed you, and my cost was around $30. It was a rotary switch. It was a Bud plastic box. And instead of using DB25 connectors, I was using RJ45 connectors, which is, again, something that we had pioneered. And we'll show a little bit of that here in a moment. But that switch box that's about to pop up here, you'll be able to see the DB25 connectors on the back. And this actually was a inexpensive Chinese version. Unfortunately, I was unable to find the deck version that came out of their accessories and supplies catalog. Much more substantial looking, thicker, beautiful brushed aluminum. And then if we go to the next image, guys, it's B3-AB. That's what my switch box looked like. And again, it was a plastic version, but it was a Bud box, a very well-known manufacturer of enclosures. And same thing, it did AB switching. What we're not showing here is the back, which had RJ45 connectors. So what generated the cash flow was, remember, $30 cost roughly,
Yep.
a $250 target price, and I sold these for $179, saving the customer, about $70 on each one.
And where did your wife ever do laundry in that laundry room?
Well, I was divorced by that time, and my recommendation is anybody that is looking to start a business and have it be successful probably shouldn't try to be a good husband, a good father, a good grandfather, because it's very taxing on your time to start a business and to make it successful. So unfortunately, by this time, I was divorced and I was able to work those 100-hour weeks and get product like this cranked out.
Oh, okay.
One more picture here, guys, BC-. And if you guys kind of keep your finger on the next button there, we're going to go through a number of images here.
Unfortunately, it doesn't work. You labeled them correctly to be in order, but they're different types of JPEG, so they're opening in different programs.
Oh, gotcha. Okay.
Yeah.
In the future, I can use Photoshop and align them all into one type of image style. You saw the house, you saw the laundry room. Well, the city of Phoenix showed up one day and said, you can't do this. This is a residential neighborhood. We had 17 people working out of the house at one point, and we ended up going into a commercial facility, which is just directly south of us here. And this was our first 2 suites that we had. And you can see the name is Gruber Associates, Computer Site Services, and the original goal was to design and build computer rooms.
Let me work on this for 1 sec, so just give me 1 minute, and I'll get the images together.
Okay. The next image there is going to be BCC-1986, and we'll talk a little bit about our civic responsibility and our helping a well-known organization actually move into the data processing space.
Okay.
There we go. That is a building in the middle of Phoenix, the Make-A-Wish Foundation. By now they have a much larger building, but it was nonprofit, a lot of donations, and someone actually donated this house to them. Once that occurred, they needed a computer room. And it was Hewlett-Packard that recommended us. Now, here's another lesson in business.
Wow.
If you do not just great work, but incredible work, you will get referrals, and you will get referrals from very large companies like Hewlett-Packard. So HP came to us, told the customer there's a company in town that can build your computer room. And since they were nonprofit, they were looking for something that didn't cost very much. So what we did was all of our people at the time volunteered their labor. We had data cablers, we had electricians, and our vendors, Control Power Company, actually, in Troy, Michigan. Let's give them a shout out. We went to them and said, look, these folks need a power conditioner. This was before the age of UPSs.
Right.
They were very expensive, and a lot of people used power conditioners as a way to keep the power clean for their computers. So there was an HP 3000 here. We got Control Power Company to give them a 10 or 15 kVA tap switching power conditioner, and our people put all of the labor to develop and build their computer room. We donated some access floor, and anyway, that's one of our first vehicles there, and you can see that the logo has evolved since then. That logo was actually borrowed from AT&T. If you remember, the AT&T logo is a blue one with a little distortion in it. And I had thought early on, a small company like mine is probably going to need a lot of recognition. So instead of plagiarizing the AT&T logo, which would have got me in a ton of hot water, I thought, let's use something similar, because subconsciously there will be an association there with a very large company and our company.
Sure. Instead of the round globe with the with kind of almost the sunburst on the right-hand side of it,
Right, yeah.
you had and theirs was blue and white, so you made yours the orange and white.
Exactly. And we've stayed with those earth tone colors. The comm division has a very southwestern theme, sunset type colors and earth tones. But it says Gruber Associates, and this was one of our proudest moments. They were so pleased with our work that they gave us, and we still have it here on display, a wishbone inside a plexiglass case. I think it's on Eileen's desk currently.
Yeah.
And that was our gift for helping them get a computer room. And I believe everything was absolutely free. Yeah, I don't think that we charged them for anything.
Well, and that's especially with a young startup company. That's the kind of stuff that makes the difference when it in getting your name out too, because there's value to Gruber to be socially responsible, and we see that today too. We still try to do that when possible,
especially in the EV world, where we're trying to move the planet to sustainable energy use and sustainable transportation. It feels good doing things like that. So we've got another picture here, guys. We talked a lot about our introduction of the modular data communications concept. What I mean by that is, instead of using a DB25 connector, using RJ45. Now, in the mid-'80s, that was considered heresy. It was considered impossible. There was two distinct different cabling disciplines. There was the voice telco world, and there was data. And data was not considered to be able to use any of the telco type wire products. Much slower they felt, those kinds of issues. So what we ended up doing was by using a modular adapter, and there's an image there, guys. It's called BDF-25 pin modular adapter. And some of these images, by the way, we had up in our first podcast. So if it seems repetitive, bear with us. There's a lot more interesting stuff coming, but I thought we'd set the stage here. This is a modular adapter that converts a DB25 to an RJ45 jack, which now allows you to use telephone type cables like silver satin back in the day. There we go. People did not think this was possible. They thought that since the mainframes have DB25 connectors on the back, that's exactly what you need. And even though you're only using 4 or 5 connections or pins, they were running 25 conductor cables from point A to point B, from the mainframe to the dumb terminal, which was, of course, a complete waste of money, unnecessary, and you had a lot of redundancy and unused wires in that cable. Mm-hmm. Now, on the image, BD-back of mainframe, there we're showing a computer mainframe, and this is in a smaller data center here in Phoenix, one that we also built, by the way. And what you'll see there is access floor and the data cabling and the power going in. Toward the middle there, you see those little blue modular adapters then transition the cabling to silver satin cables or RJ45 cables. There we go. Thank you. That big, thick black cable, by the way, was a disk connection. I forget what they called that. Something bus cable.
I don't remember right offhand.
It was the size of a garden hose. And we're talking about disk speeds or disk storage capacity of 7 megabyte, 40 megabyte, maybe 80 megabyte. But they thought back then that this was necessary. Cables of this magnitude and size.
Well, when they got the great big tub that could hold up to 150 megabytes, that was something else at the time. And yet, pretty sure that the telephone that you have in your pocket right now is more powerful than that mainframe.
Completely, yes, completely. So going back to the next picture, BDD-DB25, this is the type of cable that was commonly used to connect dumb terminals to your mainframes. And with the introduction of silver satin cables, it became infinitely less expensive, far more versatile, but it allowed something else that was very difficult to do, and that was patching. And that's where patch panels came from. Mm-hmm. Now picture a 128 port patch panel with 128 of these DB25 connectors on it with cables that are about 3/8 of an inch thick. It became a very cumbersome process to do any kind of patching, which is very handy in a demarcation room where you want to rearrange signals from time to time or troubleshoot.
Right.
So what it changed to was the next image, which is BDI-silver satin cable. And remember, people did not think that the telephone type cables were going to function in data. Now, you saw that that DB25 cable. That was probably about an $8 cable. Here you've got a cable that cost maybe $1. So the costs immediately began to decrease, and there were no issues with speed. This was the essentially Category 1 type communications.
We have one of our salespeople who still sell these silver satin cables to customers today.
Is that right? Yeah.
So, we like to talk about what new and exciting and cutting edge and stuff like that. But every once in a while, we have one customer that still uses these type of, they'll have 8-wire cables. I'm looking at the image, and I'm not sure if that is a 6-wire or an 8-wire.
That's RJ45. That's an 8-wire.
That is an 8-wire with RJ45. Okay.
Yeah, you can tell by the width of the silver satin. The 6th position is about 2/3 that.
Okay.
And the other thing was the connection method. In order to connect one of these types of cables, all you had to do was clip off the end, strip off about 3/8 of an inch, insert that into an RJ45 plug, and with a simple crimp tool, you now had a connection. With that DB25 connector, you had individual pins that had to be crimped. Then you had to insert that into the connector block. Then you had the connector block clamshell that you had to put together with the strain relief. it was infinitely more cumbersome to, connectorize anything. And if you got into soldering, and they also had the solder cup type connectors,
Sure.
that got even more complicated.
Oh, yeah, absolutely it would.
So going now to picture BDH-patch panels. Here you're going to see one of our first renditions of these silver satin cables in practice with a 128 port patch panel. Now, with the ability to do patching between, and essentially the way this worked is the mainframe. There we go. Thanks for blowing that up. So the outputs of the mainframe now, using these modular adapters, we're now using telephone type cables running to the back of the patch panel using 25 pair connectors. Now remember, in the telephone world, you had actually 50 conductor cables.
Right.
And there was a butterfly crimp tool that connectorized those. It made it a very simple process. The most time-consuming part was lacing all of the colors. And when you have 50 wires, believe me, you have to have variations in color. So it was typically a solid color with a stripe instead of just solid colors, because you
Sure.
can't come up with 50 solid colors. And if you did, they were too close where the pastels look like the other colors.
Right,
And, you
right.
couldn't see it.
Especially if the cable had aged just a little bit and had some UV
Right.
light come through.
So you had on the back of the patch panel this 25 pair connector. Then on the front, you had silver satin cables that were then patching from the output of the mainframe to all the dumb terminals around the building.
Okay.
And that was the purpose of this demarcation method. Now, one thing that we didn't have back then is cable management. And I happen to have one here with me, which we also make, by the way. If we had one of these, whoops, I got to move there we go. All right, I'm out of frame. If we had one of these in between the patch panels, now you could lace the patch panels and not end up with that hanging mess of silver satin cables. So that came a bit later, called cable management. And we make a wide variety of these. We'll talk about these here in a moment as we continue. The other thing that I wanted to show you with that image, if we can pop that back up, this is a data center not too far from us. It was at Deer Valley Unified School District, which is still in operation. You can see there's a mainframe there. It looks like a VAX 11780 with an access floor and some wooden cabinets. Our early cabinets were made out of wood. And the fundamental reason is we did not yet have a machine shop to make metal cabinets. But we did have a master carpenter, a millwork type talented
Sure.
individual
Okay.
who used to build high-end custom kitchen cabinets. And he ended up making exquisite cabinets with metal rails inside, 19-inch, to house some of the product that we were mounting in them.
Wow. Hey, we have a comment this morning as well from EV Fan. Thank you for joining us this morning. EV Fan is one of our regulars on our Tuesday Gruber Morning Show podcast. He says, I remember making cables in computer lab in high school. We'd make crossovers for the Xbox LAN parties. Yeah, that's for sure.
Very cool, yes. It was a different day and age back then. So moving along here, we didn't show much of our early production room where they made patch panels, cable assemblies. And if we go to image BDI-1986, I don't know if you remember or if you were watching the first session, but we migrated our labor pool during our growth. And one of them was we used to hire high-tech institute and DeVry students, which were technician or on a technician career with some soldering skills and, of course, the ability to read a DVM or a VOM back then, a volt ohm meter. And found that we thought that was the best way to do this.
Sure.
Well, the difficulty was, for them, it was a short-term job. They were going to go on to bigger and better things. In fact, one of the other recruiters typically would fill their head full of, you're going to be an IT manager, data processing manager, they call them back then, and you're going to get $60,000 to $80,000 per year. It looks like social media is raising our hand.
Yeah, there is no BDI 1986. There's BDJ 1986, but the only
BDJ, yeah.
BDJ, okay.
These darn sunglasses will distort a character once in a while. So anyway, we then found that we had a short-term labor pool, and it was predictable attrition. By the time they graduated, they were going to be applying to Intel, Motorola, Honeywell, Sperry, all of the types of high-tech companies that would hire those skills. And it wasn't until a friend of mine who I worked with at Digital, who was sponsoring Vietnamese refugees, finally came up with a plan that allowed us to hire Vietnamese refugees that didn't speak any English, because we hired an interpreter along with them, that eventually the labor pool transitioned to the very same labor pool that we have today. It is a very mature labor pool. They have been with us all their careers. Many of them retire, and they have, through many years of learning curve adaptation, have become extremely good at what they do because they've been doing it for so long.
Right. Many of these Vietnamese people, because they don't speak English, it's a harder thing for them to get work here in the Phoenix area, because most jobs do require English speaking.
Mm-hmm.
And so it is a win-win in both cases. We get a really good labor pool, high work ethic, and people who are very skilled at what they do. And the Vietnamese get a chance to have a job at a place where not only are they working on something that they can learn and have a skill, they're also working in an environment with a lot of other Vietnamese people, so that it gives them a little bit more comfort to be able to do that work.
A complete sense of community.
Yeah, and our Vietnamese team definitely is a community within the larger Gruber community.
Yeah. One more picture, guys. Actually, a few more, but this one is BDL. And here we can see someone wiring a patch panel. Now, we eventually moved to circuit board design. But back in the day, all of these RJ45 jacks with 8 wires coming off each one had to be laced and connected to 25 pair connectors. And that's what this young man is doing. And oftentimes there was soldering involved if we were building Balun panels, which was a way to convert coax to twisted pair wiring.
Mm-hmm.
The advantage there was a lot of buildings already had twisted pair cabling. And if you could use a Balun panel and convert coax to twisted pair, then you could use the existing cabling in the building.
Sure, that makes total sense. A lot of the early networks in the early and mid 80s ran on a token ring architecture.
Mm-hmm.
I remember helping to set up token ring networks both in school and as I first got out of school. And it was the idea that you might have 5 PCs together, and a data packet would go out. If PC 1 saw the data packet and said, "Yep, this is mine," that's where it stopped. If it didn't, they would pass it along to the next PC in line, and until all 5 PCs had their chance to grab the data packet, and that's how communications worked. It seemed like a really elegant solution until you realize you have 5 computers constantly polling one another, and it was slowing the PCs down themselves.
And the whole token ring concept. We used to build token ring cables, by the way.
Mm-hmm.
It was a very complex connector. There was nothing simple about it. But it never quite gained ground because it was too expensive.
Sure.
The whole concept. And like you said, there were performance issues. And as twisted pair cabling began to go through the category levels and became faster and faster, I think token ring was like level 1 or level 2 or category.
Yeah, it was. It would typically be no faster than category 2, which was about 4 megabits per second.
Right.
And one of the real keys was the advent of a switch, not just a hub, but an actual switch that would say, "Okay, I'm going to get a registry of all the addresses of all the PCs on the network in a little circuit board and chip, and I'm going to route the data packet directly to the right computer."
Mm-hmm.
And so the latency that you had with longer data cable connections was far more than offset by the fact that this switch would get a data packet in, it would identify where it was supposed to go, and then just send that data right to that one computer.
Mm-hmm. So just to give you a sense for the time period that we're talking about, there's one other image here, guys. It's called disk drives. So this might give you a sense for how the computer business has evolved. We've gone from computer rooms to data centers, from DP managers to IT managers. It became a broader term. And the technology, of course, changed dramatically. This was a computer room in an engineering lab, and not all computer rooms were based in standard operating businesses. They were often in research and development labs. And what you see, a lot of the gear behind Bob Bieber here, he was one of the field engineers at Digital, are various types of equipment designed to do R&D. But what's most notable about this picture is, if you notice, Bob has his hand on what looks like a cake tin. That was actually a multi-platter disc pack. There were 9 platters on this, or 9 disc. They were aluminum based with a metal oxide type layer on them. And what a computer room operator would do is, you see one in the front there. There's a pack sitting on top of a disk drive. Now, that big thing looks like a washing machine, does it not?
Yes, it does, very much.
That was a disk drive with a glass top that slid back so that you could drop that disk pack into the drive and then have it spin up with a 3-phase motor. And it took about 20 seconds to get enough speed because there was a lot of inertia to overcome. And then the heads would launch, and that's how you actually wrote and read data off of disk drives. One of the reasons that computer rooms had to be so sterile and clean, dust-free, with computer room AC units with 5-micron S-pleated filters was, if any dust got inside that disk drive, it could do what's called crash a head, or crash the heads. And that's simply a matter of, picture 2 little couplers floating on this spinning disc. And I don't know what the RPMs was, but it was fast. And some debris got in there, and suddenly this thing started to scalp. From that point forward, it would destroy that pack. You would see smoke coming out of it. And it was not an uncommon occurrence if it was a dirty data center. The other thing that's noteworthy about this washing machine disk drive, this is a CDC drive. That was an 80 megabyte drive. Did you get megabyte?
Yes.
Not gigabyte. 80 megabyte drive. And these things cost a couple $100,000 back in the day.
Absolutely. And to give you a perspective, I remember a photo that I had seen about what the head on the spinning disk drive, how close it was. If this battery was the difference between the disk drive and the head, this thing right here could be a speck of dust.
Yes, yeah.
That's how closely they ran. And so if this guy right here is running, and your heads would usually spin at 3,600 or 5,400 RPMs, and they ran into a speck of dust,
right,
chaos would ensue.
Totally. That reminds me, in my site planning guide that I used to give customers in preparation for, building their data center, that was one of the visuals that I had, was showing the flying height of a head, and then various objects like human hair, piece of dust. And you're right, it looked like a massive amount of, matter. So that hopefully gives you a perspective what these days were like back then, and during what era Gruber Communications got started. Now, at one point, we also migrated over to fiber optics. We were instrumental in that transition from DB25 type technology, RS-232, to using twisted pair. And the whole world caught on quickly to that notion. It wasn't just us at the time that was beginning to experiment with this, but we were in the state of Arizona. We got a lot of flack because the traditionalists, the DP managers of the day, didn't believe that you could run data over anything other but DB25. But eventually fiber made its debut. An interesting stat here. There are 1.4 million U.S. commercial buildings and data centers that are using fiber in the United States. which it's according to this survey is about 28% of the total U.S. commercial sites. So why is fiber better? Well, in a nutshell, and we've got a much more detailed discussion here in a moment, it has greater bandwidth. Copper can't even come close because fiber provides much more bandwidth than copper and has proven performance at rates up to 10 gigabits per second. There is no near-end crosstalk. Near-end crosstalk is the result of running data signals over copper wiring. And remember, when you're pushing electrons through copper, you have a magnetic field. So here's your wire. Around this wire is a magnetic field. If you have another wire right next to it, you can get some coupling, which in the data world is called near-end crosstalk, and they go to great lengths as they continue to increase the speeds over which they can run data over copper to break up that magnetic field. And the simplest way to do it, I can't twist it properly here, but to twist the wires together to break up the magnetic field. So that's one way. Fiber doesn't have that problem. It's non-conductive.
Correct.
It does not have a magnetic field. It's not pushing electrons. It's pushing photons. So there is no next. The other thing that is that makes fiber even better than copper is, in order to hack into something, it's not that hard if you have a magnetic field that you can couple into. With fiber, you don't have that.
Right. That's in other words, you can wiretap somebody's conversation over a copper line, and you cannot over fiber optic.
Because if you wiretap fiber, you've broken the connection.
Right.
And you immediately, or the hardware immediately recognizes nothing's getting to the other end.
Right. And there's no loss of light as it's going through the fiber, unlike what our cables in the background show.
And we also install fiber optics, by the way. And one of the coolest piece of equipment that we have is a piece of equipment that can spot if there is a fiber break precisely where it is.
Yeah, it's able to take and it measures through doing light measurements, measurements of the light. It can tell how far a break is in a long fiber cable to within a few inches.
Which makes troubleshooting, of course, very simple, especially if it's underground, because you don't want to dig up 50 miles of fiber to find the break. You'd like to be able to isolate it and bring your backhoe right to that spot. Fiber is also invisible light, and it's a much larger bandwidth or more data. At this point, if we can bring up a spectrum picture here from, it is called fiber dash spectrum, light spectrum. There we go. And let's do the transformed one because that's a little bit bigger image. So fiber dash light underscore spectrum dash transformed. And here you'll be able to see where the data portion of fiber resides. Off to the left there is the spectrum that we can see. And it's all the way from the ultraviolet to the infrared spectrum. By the time you get to 850 nanometers, you're now beginning to use fiber. 850 nanometers is multi-mode fiber.
Correct.
And 1300 is single-mode fiber, and then there are variations in between as well. Now, one of the ways that, one of the tools that we use to test if the fiber has continuity is we can use visible light. It doesn't mean that that's the data that's going to run on this, but it will allow, or it is, visible to the naked eye, so you can see that you don't have any breaks in your fiber cable.
And that's why if a fiber cable is plugged into a fiber optic hub or a PC or another piece of equipment, part of the light that goes through that fiber is going to be up in that red visible light range. And that's specifically so the person who is looking to see if there's a problem with the fiber can see that something's actually coming out of it. One of the last things in the world that you'd want to do would be to put that fiber right up to your eyes like this and look at it, because that invisible light will damage your eyes.
Right, right. And then the final thing that I had here was glass is cheaper than copper. It turns out that glass is the second most plentiful element on this planet.
Right. It's basically silicone. It's a form of carbon almost.
Right. We can probably bring up one more image here, fiber-light, single mode and multi-mode, SM and MM. And on that image, you'll be able to see where fiber communications, in what spectrum it will operate. And you can see the multi-mode there, with actually 850 being the first one. And they have some colors there too for the jackets, which is one of the ways that you can identify whether it's single mode or multi-mode.
Now, while neither you and I are necessarily the fiber experts, our account managers are those, I can explain a little bit of what goes on between these single mode and multi-mode fiber types. For example, OM1 was the first generation of multi-mode fiber. It was good for up to about a gigabit worth of bandwidth speed. The cabling was orange, and it had a 62.5 micron fiber. OM2 is very similar to OM1, but it has a 50 micron fiber width, and it because it's a little bit of a smaller piece of glass, it's able to get speeds that are a little bit faster, up to about 4 gigabits a second. OM3 went back to the slightly larger, the 62.5 micron piece of glass, but it can do 10 gigabits, and in short distances can even do up to 40 gigabits of data throughput. And then OM4, which is the current best standard, OM5 is still being developed, is back to a 50 micron cable. One of the challenges that people in their data centers have with these different pieces of fiber is the color. Fiber is defined, unlike copper cable, which you can get any color of the rainbow, and whatever you want. It's it's category 5 or it's category 6 or whatever. The type of fiber you get is largely defined by the color of the jacket that you have. So if you see something with an orange jacket, a little bit larger jacket is going to be OM2, and a little bit smaller jacket color is going to be, OM1, and the smaller jacket color is going to be OM2. Well, OM3 and OM4 look so similar to one another with that aqua jacket that it's almost impossible to distinguish between the two. So in Europe, they started to go to a violet or purple jacket like this. And we're one of the few people, or one of the few companies in the United States that sells this violet fiber as opposed to the aqua fiber for OM4.
Interesting. These are SC connectors, and we'll talk about some size in a moment here. Guys, if you can bring up an image called fiber diameter comparisons, we'll do that one next. This little cap that I took off, I have revealed a ceramic ferrule, which is about a 1/16 of an inch in diameter. And inside that ceramic ferrule is the fiber strand. And what we're looking at here on this image...
You had the image up.
Yeah,
you could go ahead and put it
good.
up again.
Yeah. So the typical OM1, the multimode fiber that Mark was talking about just now, is 125 microns cladding. Now let's talk about fiber for just a moment. It wasn't until the 1800s that they figured out that you can bend light.
Mm-hmm.
You know, if you're shooting light on the surface of the planet, well, of course, I'm about to say something that may be inaccurate because I think physics keeps changing. I think that light bends as it continues to go out light years and light years. But generally, it's been accepted that it will not bend. It will just go straight.
Okay.
But what they found was that if you illuminate a stream of water, the light follows the stream.
Yes.
All right? That is the fundamental principle behind being able to use a fiber optic glass cable and have it have twists and bends and, up to a certain level because of that principle. So they have a jacket around the outside of the fiber, which is a protective sleeve. Then there is the fiber strand itself, and there's cladding around the fiber, which does a couple of things. It protects the core, and it also reflects some of the light back to the core. There's some images where they show little arrows, and as it bounces out, it gets reflected back to the core, increasing the bandwidth of that core. On a multi-mode fiber cable, the core is 62.5 microns in diameter. If you look at the typical human hair to the right there where Mark is, now it depends on your nationality and how thick your hair is. I have thin hair, so I might be, this
Yeah,
might
your
not
hair's
work for
pretty
me.
thin.
Yeah. But you can see that core is actually smaller than typical human hair. It really gets severe when you get down into single mode fiber, which is just below that multi-mode where they're showing 9 micron core. And despite it being that small, you can literally get miles of data through something like this.
That's right. One of the main differences I know between multi-mode fiber and single mode fiber has to deal with the amount of light that you can put through it. And it's not just that it's a physically bigger core. Multi-mode cable will allow multiple light wavelengths to pass through it all at once. The disadvantage of that is that multi-mode fiber can only run that way for a few hundred meters. OM4 is the champion of multi-mode at high speed at about 500 meters. Single mode cannot transmit as much data. It's a smaller core physically, as you can see. It's about 1/8 the width of a typical human hair. The advantage to single mode fiber, however, is that you typically do not have to re-strengthen the fiber connection for as much as 5 kilometers.
Amazing.
It's close to 10 times the length that you can go with single mode fiber, and that's what allows things like fiber optic cables to be laid across the bottom of the ocean, because even the ships can take and put the repeaters basically down under the sea, and they don't have to worry about having a repeater every few hundred meters. They can go and lay 4 or 5 kilometers of cable.
Amazing. You know what? We're pushing towards an hour. What I'm going to suggest is we've got a lot of content here related to fiber, the history of fiber, some of the advantages of fiber. I thought maybe this would be a good segue to save that for the next podcast and talk about some of the products that we brought in here.
I think that's actually a really good idea. Why don't you tell us about this guy right here?
All right. So what we have here is what's called a rack rail. And this is something that fits into a variety of different types of cabinets or racks. It doesn't matter what width they are. They can be 19-inch, 23-inch. A lot of our other products have to be sized to the width of the rack. This, for example, is a 19-inch rack mount because it's 19 inches wide. The 23-inch version has to be a different different wire manager. With this, since it's split, you are able to put it into any rack or into any configuration. Now, where this came from, this will allow you to place a box, a computer case, a shelf, piece of metal, whatever it is, inside a cabinet or a rack. And I first saw this on eBay many years ago, probably over 20 years ago or so, and I thought, what a novel idea. So I bought one off eBay, and the product that came to me was rattle can black painted. In fact, some of the paint had already peeled off by the time it got shipped because it wasn't dry enough and the bubble wrap adhered with it.
Okay.
It was a fairly low quality product, and it had holes in it instead of PEM nuts like we have here, so it was not adjustable. So what we did was we reverse engineered the part, and we thought, maybe this is something we should offer. Sometimes when we find a cool product, if it's high quality, we'll we'll just buy it from that vendor and then remarket it.
Right.
In this case, it made more sense to improve the product, and our machine shop, Chaz Leitner, run by Chaz Leitner, is top notch. They actually improved it to the point where it's now fully adjustable. You have PEM nuts, which mean that it's a pressed nut into the metal, and you have slides here, so you can essentially change the length and the width of this depending on what kind of cabinet it's going into. This product, in short order, became our top-selling product within a span of maybe 2 or 3 years. And I don't know where it ranks today, but
It is still our top-selling metal product, and it's one of our top-selling products overall. Some of the fiber optic cables that we produce do sell a little bit more in terms of volume and in dollars, but for metal, this is it. And one of the reasons for that is because it is just so flexible.
Mhm.
You know, typically a computer server will be 19 inches or 18 and a half inches wide, and it'll have a specialty rail that will bolt onto the server and then onto the cabinet, and it'll be usually a lot of times it'll be two pieces. One piece is on the server, one piece is on the cabinet, and it's almost like installing a drawer in a kitchen cabinet.
Mhm.
And if you don't get it just right, it doesn't work. And lo and behold, if you switch from an HP to a Dell server or to an IBM server or something, all bets are off, because these servers all have their own very specific rail configurations, and they're not compatible with one another.
sure.
Well, these rack rails are compatible with everything,
Mhm.
because the inside where the nuts are, they're low profile screws, and the PEM nuts give it strength to be able to hold higher weight. This simple 1.5, 2-inch lip on the bottom of the rail allows you to put anything under there. It doesn't matter what kind of server it is,
Mhm.
as long as it's something that's between 16 and 18 and 3/4 inches wide. It fits.
Mhm.
And as a result, it's incredibly flexible and has become incredibly popular. It still is one of our best selling items overall.
And the flexibility that we have here in our machine shop allows us to do things like this. We originally had 2 rack space cable management panels like this, which is about twice this height. And then a customer said, well, you know what? Can you make it slimmer? I don't need that much cable management. So we came up with this product. Then we had a customer that said, I need something deeper. I need it narrow and deeper. All that needs to be changed when you have a modification like this is the programming on the punch presses that punch out the metal.
Right.
Anything can be accommodated. The most recent variation of the standard 5-ring, 5-inch deep cable manager was this one. I had a customer that said, you know what? I need a really small one. Can you do that? And that's where this came from.
Well, and they're using things like this miniature or mini Cat 6A cable,
Right.
or fiber optic cables, and they said, I don't need a great big, heavy, wide rack space, because the cables that I have don't fill anywhere close to that, and I want the space for other stuff.
Right. And then picture something else, which is a product that was recently developed. Okay, picture a double height cable management panel like this. And we had a customer that said, you know what? I'm not only patching in the front between patch panels and routers and switches and hubs, but I also need access to the rear without having to go around the rack,
Yes.
the 19-inch rack. So we ended up putting holes in here, slots. They were rectangular type openings, which then allowed the customer to put cables into the back or bring them from the back to the front without going around the rack. The bottom line here is our versatility is virtually unlimited, only constrained by your imagination as a customer. So if you have unique requirements, and it even gets into color, if you don't like black, you tell us what you like. You can get powder-coated pigments in any color you want. If steel is not your preference, if you want aluminum, if you want some other type of metal, that's also available.
Mm-hmm.
How about stainless steel? we'll make it look like a DeLorean.
That we certainly could. Brushed stainless steel would be quite the feat to do, and
Yeah.
that'd make a very interesting looking set of racks. That's for sure.
But that's one of the reasons that the customers come to the Gruber Communications Company, is because of our flexibility, our versatility, and our willingness to adapt to their needs. And we do small run. You try to go to some of these larger companies and try to get 50 of these built, or even 500. They're going to shake their head and go, well, you're not going to like the minimum order quantity. We're able to do small run and accommodate any customer's needs, only limited by their imagination.
Over the next several weeks, I know that we'll talk about this a lot. You mentioned small runs. You've also hit on one of the things that's become a real core tenet of the Communication Products Group, and that is that we will do what others won't.
Mm-hmm.
If you come to us with an unusual cable and say, I don't know what this is, I don't know where to go, I can't search it on Google because I don't know what to search for. We tell you, bring a sample to us. We'll reverse engineer your cable for you. We'll return it to you. It will be non-destructive, and we'll tell you what it takes to get it done. Being able to do what other people can't do, kind of like what you mentioned last week in your early business, you do what other people can't, has become one of the hallmarks of what we do here. The other hallmark being, we will do more quickly than what other people can do.
Yep.
What other people might take 6 weeks to do, we may be able to get done in 6 days.
And as you've noticed, when a project comes along that has a timeline that doesn't fit into the normal 8 to 5, our people work overtime, they work weekends, we get the job done, and we take care of the customer.
Absolutely. That's a big part of where our culture is at in the entire company.
Well, it looks like we're coming up on an hour here. We appreciate all of you joining us. We are, make sure you hit that like button and make sure you subscribe. That's what's going to feed this channel and allow us to continue to provide good content. Next week, we'll focus more on fiber. The history of fiber is a fascinating one, and some of the advantages that fiber brings.
Yeah, we'll get into more about the different types of fiber, some of the advantages and not, like you said, and maybe even have one of our account managers in as a guest this next week as well.
Was there someone that volunteered?
I have not. I know that the one that we want to come in is in Jamaica this week.
Okay.
And I don't think he's back next Monday, but he'll be back within 2 weeks. But we continue to talk, and it's a possibility.
Good deal. Well, again, thank you for joining us. We appreciate you being part of this podcast, and we will see you next week, Monday morning.
Take care.